Welcome. When people talk about additive manufacturing, they're quickly discussing the application, the number of units, or the possibility to replace mass production. Not so in aerospace. Here it was realized early on that AM offers possibilities that are ideally suitable for this industry. Basically, in the aerospace sector, we're talking about small quantities, high production costs, and lightweight construction and increased efficiency. By using additive manufacturing, it is not only possible to save weight, but also storage space, time on the ground, development times, and of course, most importantly, costs. But what about the industry when most of the aircraft are forced to stay on the ground? When large orders are cancelled or postponed and uncertainty determines the strategic behavior? Or is additive manufacturing exactly what gives the industry a boost or points the way forward in those difficult times? What will the impact of additive manufacturing be like in the future? Of course, we also want to know what is happening technically. Which components are now being printed? Which materials dominate and which technology? And finally, there's space travel. Remember the sentence by William Shatner, "Space, the final frontier." How is AM doing here? The first 3D printer is already in space, but the more important question is how additive manufacturing is driving the actual spaceflight development. All these questions and much more are addressed in our panel, AM, a boost for aerospace, current and future influence of AM in the space and aircraft industry. And here again, I'm lucky enough to talk to fantastic guests and therefore welcome them digitally. Eliana Fu, Senior Engineer Additive Technologies at Relativity Space. Professor Dr. Jens Telgkamp, Professor for Additive Manufacturing and Production Engineering at HAW Hamburg. And last but not least, Hauke Schultz, Additive Manufacturing Roadmap Leader at Airbus. Hello together to all of you. How are you?
Good, hello.
Perfect, good to have you here. Eliana, we need to start with you because I mentioned it last. For decades, or rather centuries, many people have dreamed of going into space and exploring new worlds, like William Shatner said. What does 3D printing and relativity space have to do with it? What are you doing for reaching this goal?
Well, good morning. So great to see you. It's just gone 8 a.m. here in Los Angeles. So I'm just starting my day. You guys are finishing your day. I'm Senior Engineer for Additive Technologies at Relativity Space. We are a relatively new company in the era of space exploration. And so we see 3D printing as the tool or the enabling technology that's going to help us build humanity's multiplanetary future. We've chosen 3D printing as the method in which we're going to do that via Terran 1, which is the name of our fully 3D printed rocket. And so that's why we've chosen additive manufacturing as a way forward.
Great, thank you so much. Hauke, I mean, you're really experiencing hard times right now, I would say. Many jobs are being cut, especially at Airbus. Production has been significantly reduced and further cost-cutting opportunities are being explored. So, I mean, you are responsible for the whole AM development at Airbus. Are there still investment made, or is it all about to being cut, or is the current situation rather now more than ever? So, what is happening in your area, and how is Airbus doing right now?
Well, short answer, AM is very much still alive at Airbus and elsewhere, I would say. Of course, we had a significant impact of COVID in all over aviation. And in Airbus, we have worked very hard in the last half year, I would say, on adaptation. And I was quite happy seeing yesterday that we have good news on a vaccine. But yeah, additive manufacturing is still a very suitable technology for aerospace, and we keep it running in operations, of course, in serial production. So it's clearly reality there already, but also we keep investing in it in R&D. then is it even a boost in the crisis? I would say for sure, at least the crisis shows a lot of benefits of additive manufacturing actually. It's clearly a very flexible technology. So when you have supply chain disruptions, you have missing parts in your assembly lines. Often AM additive manufacturing can jump in and supply these parts, but it goes also in the other direction that additive manufacturing suppliers might have it a bit easier than other suppliers because their machines can be used more flexibly for other industries. And let's not forget face shields, which have been manufactured in 3D printing in the beginning of the crisis. But also looking further ahead, we had to adapt our priorities a bit. And Airbus has a few weeks ago published our plans for a zero-emission flight. We showed 3 concept planes, and on my side, absolutely intent, and it's very clear also with these programs that AM will play a major role in this.
Especially looking at the fact that a lot of orders have been cancelled, and we can expect that at least in the coming years, the aerospace industry tries to focus more on maintaining planes. So what about maintenance of planes? Is that a strong topic that you are dealing with in the AM? So how many parts can you already...
So we have identified from the...
Pardon, sorry, go ahead.
Yeah. Well, we have identified spares after sales as a key sector for additive manufacturing from the beginning of the story, I would say. And we have supplied a 4-digit number of parts to our customers of additive manufacturing parts. And I'm happy to say that again 3 weeks ago. We also published on the first metal powder bed fusion parts that we supplied to an US customer of ours for an AC20 CEO, where a casting part went out of production. So the mold was not available anymore, and with additive manufacturing, with metal powder bed fusion, we were able to manufacture this part in a quite short lead time, without investing into the necessary toolings for the casting process again. So yes, AM also keeps playing an important role for spares.
Great insight. Thank you so much. Jens, last but not least, you have moved from Airbus to academia. What current trends do you see in the industry when it comes to AM, and what are the current activities in your area, in your field of working?
Yes, so finally, last but not least, good evening also from my side, or good morning if you're on the western side of the Atlantic Ocean, of course. So, yes, I have been 18 years in Airbus, so exploring the aerospace world from that. And now I stayed with my favorite technology, additive manufacturing, but for a different employer. So first, my new job gives me the opportunity to have a little bit an independent view over aerospace, which is focused today, but also in general. So what can I say? First, if I browse over the aerospace scene, I see that most companies during the last 5-6 years took some decision, all going in the same direction. So they focused a lot on serial parts. So they could also go for tools and stuff, but it's relatively small in most aerospace companies. They focus a lot on flying parts, on serial parts, no matter if they are helicopters guys or aircraft guys or rocket and launcher guys. A lot of flying parts there. They focus to a certain extent on parts with a high value creation. So not simple helper parts, but really parts also in the safety critical regimes. With advantages and disadvantages. I mean, it's complex to do that, and it leads to a long process chain. But of course, the value creation is there if you manage to do it right. They focus a lot on supply chains. I mean, I don't know a single big aerospace company who would say, this is core for us, we produce all parts ourselves. The question in most companies is really how to build up a robust supply chain for these parts. And most enterprises, they operate some printers on their own to establish and manage the process, especially if it's safety relevant, but then they rely on building up their supply chains. And they focus on getting really the process qualified, which is very ambitious, because it is more ambitious than many aerospace companies do for casting parts, where they do a lot of single part qualification. They really want to certify the whole process to come to certify parts from that. So they are ambitious. And of course, this makes it not too easy, but at the end, it leads to value creation. And the second part of your question was, what am I doing now? Well, I'm still observing aerospace, but a little bit higher, so not only from inside Airbus view. And I also do some other things, like I develop some adhesive films for 3D printing, for mobile and electronic industries. I do some classical mechanical engineering, where, of course, the business case looks quite different from aerospace, which confirms the aerospace view that I just gave you. And I look at some combined process also for some improved tool building and stuff like that.
Great, thank you so much for the insight. Hauke, question for you. I read a statistic, a saving of 1.5 kilograms in weight results in an average saving of approximately 65,000 liters of kerosene a year. Is the current increased environmental awareness due to such figures also a driver for you? Do you see, I mean, beside the crisis, that the focus on sustainability pushes AM and the aerospace sector forward?
Yeah, absolutely. I would say absolutely. So I think I ended my last answer with our ambitions in zero emission flying. So this is really our new vision, our new target, concrete objective. And well, to be honest, with our existing aircraft programs in the past, it's not super easy. We have always been very interested in topology optimization. So having weight savings. I mean, we're aerospace. That's what we do. But on existing aircraft programs, saving part by part, 0.5 kilogram, doesn't bring you so far. So we can't really go to our airlines and say, look, we saved 0.5 kilogram. Now pay us on top what you're saving during operations for the 65,000 liters of kerosene. So now looking at these new programs that we are targeting, zero emission flight, for two reasons. This is really, really interesting for us, and sustainability is a key target for us. On the one hand, because in this completely new program, we can think AM first time right. And we can really focus on increased performance of the parts, on weight saving, and make big packages which go into the statistics, I would say, of the product, and sell it to our customers. But also we are not focused on only weight saving and structure, but we also really look at functional parts, at parts where additive manufacturing brings in a unique solution. So parts like manifolds or heat exchangers, complex system parts, which cannot be manufactured with conventional subtractive technologies. So this is very interesting and brings huge potentials for scaling up the implementation of additive manufacturing. Still, if I add one more point, so this was focusing on CO2 in operations, which is probably the biggest driver, quite clearly the biggest driver in aviation to be more sustainable. But at Airbus, we very much also want to establish a circular economy and improve our use of primary raw materials. So here again, additive manufacturing brings great benefits in producing near net shape parts, having a lower buy-to-fly ratio. But we are also looking in recycling typical materials or more or less waste from other processes, chips for machining, or CFRP residual materials into powder for AM parts, or into short fiber reinforced polymer raw material for AM again. And this, of course, with low energy input, this is the target to reduce the overall environmental footprint. Yeah.
Great. You should have a look into Formnext Impact Award because it was won by a company that is recycling metal into a new powder called Molyworks. So probably a good idea to connect to each other because they can help you out here for sure. Jens, normally part goes through a series of post-production tests and release procedures, and I think especially in aerospace industries, there are quite heavy restrictions and preconditions you have to fulfill. What is the status here in additive production? Because it's a totally different process cycle. Are there already relevant certifications in place, and is time safe too with all the post-production tests included?
Mm-hmm. That answer directly connects to what I was saying about high-value parts, which are often safety-critical parts, and these can be the hydraulic or heat exchanger type of parts. This can be topology-optimized parts, but also what Hauke said, this can be near-net shape, direct energy deposition parts, which are very much near-net shape. So for all of these parts, when they are safety-critical, safety is not for debate in any aerospace company. So safety is given by very strong safety regulations. And all of our companies need to comply with the regulations and need to prove the safety for sure. And in order to achieve this with a relatively young technology, such as AM is altogether, you need a long process chains. You need to do many post-treatment steps to ensure the internal quality and the surface quality of the parts, but also to inspect the inner quality and the surface properties of the parts. So safety is not for debate, which means you can do safety critical stuff today with additive manufacturing, but you are paying this with a relatively long process chain that you need to do to qualify or certify parts. The way to get out of this is continue to research. For example, to bring online monitoring to a point where this works more maturely. But it is not only technical research, it is also gain experiences and gain proof. Mm-hmm. Before that, you will not be able to show to certification authorities, for example, that with a shorter process chain, you can deliver the quality and the safety that they expect for certification. And this is not new. I told you already that we are ambitious on AM. For me, this is important. We are not just slow, we are ambitious. We want to have more than we have today in many sectors for casting and forging parts with a process qualification and so on. So we are ambitious in that case. And then this was done also for other technologies. This is something that I remind you of. For example, any safety critical bonding applications in any industry was going through a process of learning over many years before they could prove that the pre-treatment for the bond line is really the central step. If you monitor the pre-treatment in a certain way, you can ensure you get quality bonds, and you can also do some safety critical stuff with all the additional safety measurements and chicken rivets and kind of stuff. So that kind of learning curve is also possible for additive on top of the research that I mentioned, but it needs to be done, and I think it's starting. So this is my understanding of the way to shorter routes in terms of time and in terms of cost, because all those steps cost you money, and in terms of safety, which is for sure not a debate, but with the new technology, you have an improved means of compliance and a shorter physical process chain. This is my view somehow.
Great, thank you. Hauke, you mentioned that there is already a spare part certified delivered to a customer. How did this process work in terms of certification, defining standards, and how was the acceptance on the other side? Is it a critical part, or can you tell us a little bit more about that, or as far as you are allowed?
Well, well, it's not neither easy, and no wanted to give all the details, of course, but yeah, sure, I can talk about it. So the part to start with, of course, was not a class 1 part, as we say, so not a part if it would fail, which it will obviously not, but purely theoretically. the aircraft would survive it. The part has been manufactured in a process qualification internally in our Airbus commercial reference shop in Filton, UK. So there we have a process qualification, as just mentioned by Jens. It's a titanium part. So the production route is the same as we would use for serial manufacturing part. Then the certification is a bit different for spare parts. You need to create also the engineering definition set, which is created for the existing program for the casting part. So you need to create a new version for the spare part. And but we created a process for that, focusing also on the ability to be fast, because again we are talking about spares and lead time is key here. Then on the certification, on the technical aspects, so it's very much again as Jens explained, we have to be very sure about safety. So we do NDT, of course. We do CT during qualification processes. Initial qualification process in serial production is typically 2D X-ray. We do fluent penetrant inspection to identify surface defects, and of course, initially to achieve the process qualification, we do very exhaustive test campaigns, producing a lot of specimens for various mechanical properties, and to make sure that that the process is delivering the right material quality. But even again, on top of this, we are tracking key process parameters all the time to assure that also the repeatability and process stability is given. So overall, it's challenging, but it pays off, and it's still much faster and cheaper than starting a new casting qualification on a part level.
Very important to know. Eliana, I mean, we talked a lot about aerospace and we're talking about big parts. You mentioned at the very beginning you are planning to launch a completely 3D printed rocket into space. Don't get me wrong, but
yeah, I know it sounds very ambitious.
Sounds crazy.
A young company.
So how is that possible? And let me add the second question: how aviation can benefit from your ideas, because you are not using a typical 3D printer, right, for building that rocket?
Yeah, all good questions. Actually, we are taking some lessons from commercial aviation and commercial aerospace that are already using 3D printing. Obviously, they kind of led the way in this area. But how space exploration or space flight is taking that to the next level is by thinking totally outside the box. So by not constraining yourself to, let's just say laser powder bed, we are also using laser powder bed for our engines. So this graphic that I have behind me is showing you a hot fire test of laser powder bed printed nickel-based engine. So that is something that we are actually doing right now. But our own printing device or method, if you want to call it, we call it Stargate. It's actually based on a kind of advanced MIG welding process, which is basically wire arc additive. So it's not entirely new, but it's kind of renamed and reimagined. And so that I think the difference is with laser powder bed, especially in the supply chain. So you mentioned supply chain earlier, and that's also very, very important to us. There are lots of people in the supply chain that can do laser powder bed and actually probably can do it better than us. So why not take advantage of that? But there isn't anybody out there who can do the wire arc additive process on a sort of service bureau basis. There's very few people who are even approaching the size that we're doing. I think maybe in US, maybe Oak Ridge or WAM in the UK with Cranfield University, but they kind of tend to go long and flat, and we're going big and tall. So really that's the only way to get the large sort of structure, to have a 3D printing or additive process where you can deposit quickly, you can get the kind of size and structure and overhang that you want. And then what the whole process is doing is giving you control of your part manufacturer. And so you're not depending on the supply chain at that point. You're doing everything yourself. So it's taking back control of you for your product that you want to send into space. And then the whole thing, what the concept is allowing your customer who wants to fly on your rocket a faster access to space.
But that leads me to my next question, Eliana, if I'm allowed to add one again. What is, I like your concept, and it's very clear. You want to 3D print a whole rocket. But what's afterwards the application, the aim of the rocket? What should the rocket do? I mean, this is a question we didn't raise in our pre-conference. So what is the target with your rocket? What should be done?
Well, right now with Relativity, we actually have signed a couple of customers. So those are mostly commercial satellite customers like Telesat and New Space, but we also signed Lockheed Martin. So those are completely unmanned flights right now. And there's plenty of room in space exploration for crewed flights, have we seen with Boeing and NASA and, SpaceX. And then also space tourism that people are interested in. But there's also room in the space for uncrewed or unmanned flights. And so that kind of thing where we're just launching satellites to gather information or telecommunications, those things are still going to be going on. So there's plenty of room for everybody. But I think your ultimate question is, will we see 3D printing in space? And the answer is yes, because we're already doing that on ISS. Right now, it's just limited to polymeric, but you can see other materials being imagined for extraterrestrial printing. As we reconquer, shouldn't use the word conquer because that sounds a bit un-PC. As we go into further space exploration in the near solar system, there could be planetary bodies that we want to investigate. And so 3D printing, when you need a spare part or doing repair, and this is just exactly the same as commercial aerospace, is going to be a key enabling technology to do that. It's very difficult to take a 500-ton forging press with you onto the moon, for example.
True. I mean, you heard a lot of the problems the colleagues are mentioned there. Hauke, Jens, you heard what Eliana was telling you about their current development. Is there any kind of connection, anything you can learn out of the development in the spacecraft development? Is there like something where you can help each other? Jens, where do you see a connection?
Yeah, I think this is something which is altogether not fully exploited. When you look at different industries, they are in different phases of AM application. In some of my keynotes, I use a slide where you see an automotive product, and it's not really expensive. I mean, the single parts are not expensive. The price of the whole car with the weight of the whole car makes that it shows that it's only 20 euros per kilogram of car. Aircraft are 200 times more worth, and satellites and launchers are partially 10,000 times more worth. So this shows that in Eliana's products, we have already now a lot of opportunity to earn money with a flying application for additive manufacturing. Then aeronautics, aircraft industry is somewhere in between the car and the launcher. In the car, they are still doing prototype building because they have not yet any business cases for serial parts. The question is maybe after aerospace, after the launchers have left this regime of being the only one with a business case for flying parts, the aircraft are coming, and later the cars are coming. How can we ensure some knowledge transfer between these industries? I think we need some appropriate formats to learn from each other, even if we are in different phases of the application. Not because we are differently quick, just because what I explained to you, the products are so different by nature that Eliana can today do things that maybe Hauke can do tomorrow and automotive can do even later. So how do we systematically learn? I don't know. Maybe you are missing still the right exchange formats, or do you have any ideas or comments on that?
Hauke, something you want to add?
Yeah. Well, I think the point is very, very fair to learn from each other and learn from space. So in Airbus, we have the nice situation that we have different business units and that we have both space and commercial, and we can clearly benefit from each other there. So even though I have a commercial airplane behind me as a background, my function as AIM roadmap owner or roadmap leader in Airbus covers actually the complete group, all business units. And clearly we have a regular exchange there and we're learning from each other. And as explained by the other panel members, in space, we have the very nice opportunity that each kilogram of material that we are, or part that we're producing is already quite expensive. It's expensive to bring it into orbit. So each kilogram or each half kilogram that we're saving there is worth a lot of money. So you have good opportunities to implement additive manufacturing on an increased performance basis in space. And so you find a lot of really upstream fancy applications actually also in Airbus, which then we can learn from in Airbus commercial. And yeah, to be honest, actually, we were discussing recently a video from Relativity space because it was looking quite similar to what we need for hydrogen airplanes if we think about tanks. So this might be also a good opportunity for further exchange.
Okay, yes, call me later.
Okay, yeah, that sounds pretty good. So there are
already working.
Yeah, we are in a panel. That's a good thing. So there are similarities as far as I see. That's pretty good. Let's talk a little bit, just a moment, about startups, because Eliana, would you consider your company as a startup? Yes, I take that as a yes.
It definitely is a startup. Yes.
Okay, cool.
The company it was only formed about 5 years ago by two people who were once interns at Blue Origin. Mm-hmm. And then when they graduated, they started full-time jobs, and they used to text each other, oh, it's so frustrating to get this part. Why don't we just 3D print it? So that's how the company actually came about. And so the startup culture is quite different from being in a company with, 150,000 people or 100,000 people. We have just about 200 people right now based in two sites, one in California and our test fire stand that you see in this image here in Stennis, Mississippi. That's actually a NASA facility that we rent. And so there are actually lots of, if you look in the news, new space tech startups, and a lot of them are privately funded because investors are looking for the new thing to make money from. But more so than that, it's also a different way of working, a different way of collaborating, learning, and manufacturing. And it is using something like 3D printing or additive, really, to instead of doing the traditional way. So the whole thought process is quite different too. And it can be very attractive for young people, especially people coming out of university, looking around and trying to find what careers they want to go into. So actually through this summer, I've had a lot of people contact me because we are hiring during COVID. But I would say that there are even startups and tech startups for the space exploration in other countries. I mean, I just read about a couple of new startups in Germany actually starting for space exploration. And no doubt 3D printing is going to be something that is very, very useful tool to quickly achieve your goals.
Great, thank you so much. Hauke, question for you. I mean, I know a lot of guys at Airbus, and I would call it more the traditional company, although you have been quite innovative in the last couple of years, thinking about the small airplanes you are close to launch, where you can deliver planes for lower demand of passengers, but still economic-wise perfectly developed. But what is the status of startups with Airbus? Are there many startups approaching you? Shall we work together? We have an idea that you probably can implement. Is Airbus actively looking for startups in the field of AM? And is it part of your job?
First, the startup scene and the startup mentality is very interesting and important for us because startups can bring a very high agility, and you can develop things faster. I mean, you have a fail fast approach, which is not always so easy inside a bigger company of Airbus, but we try to implement this mentality internally with things like a protospace, or we have certain incubators where we try to develop things very fast. And actually, additive manufacturing was born in this kind of environment, or pushed forward in this kind of environment quite some years ago by now. But further, we also look at startups outside, of course. So we have a scheme that we call the Airbus Biz Lab. So startups can apply and can actually be hosted by Airbus in certain environments to be close to Airbus, to get some kind of mentoring from Airbus and have a closer partnership there. And on top of that, we have a kind of a subsidy, A-Cube, which is also directly investing in startups. Then is it my job? Well, if you talk about additive manufacturing, for sure it is my job, and we have to be humble on our side. We cannot develop everything on our side ourselves, and the external market is often much faster than we internally. So we need to keep in contact what's happening, and if there's a startup with a very promising idea with huge benefits in additive manufacturing, then yes, it's also my job to get in contact with that and see, is it beneficial for us? Should we get into a closer partnership? Yeah.
Great. Jens, a last quick question for you, and then we need to step into the question of the audience because there are a few. How do you see the interest on the educational side? So do you experience a run on the topic AM at the university, or is it rather like always?
So courses are typically quite well booked. I mean, if they are not booked in this topic, then probably you're doing something wrong as a professor. Luckily, mine are booked. So when it comes to content, it's clearly not enough to give people technology overview, but the overview needs to encounter also the topics of supply chain build-up, supply chain models, and so on. And of course, product development. I mean, already Airbus had started to bring some new design techniques, which are related to simulation and so on, from the expert mode into the standard mode. Because if you cannot simulate an additive part being built, or if you cannot optimize it for additive in terms of build cost, supporting, and so on, then you're not good. So Airbus started this already mindset-wise, and maybe this is also the reason why some universities give a call to people coming from the design and product development side rather than pure materials and technology, because additive is more than materials and technology. It's really also about product development, and it's also about the supply chain build-up. So I think some professors in my generation, or even younger, which is easily possible, honestly, they are trying to bring this spirit into the universities. And this is important. And the last thing I want to say is just one keyword, hands-on, which means have rather courses with really practical topics, operating the machine, designing a topic as a homework or project work, rather than just listening to the lecture and doing the exam at the end.
Probably the right way. Let me address some questions of the audience. Eliana, Louis McBride asks, what alloys are you printing in usual WAAM? What your key component requirements, for example, LCF, HCF, etc., and what have been the key difficulties?
Yeah, those are great questions. Well, so we are approaching, I guess you're talking about the Stargate process with the barrel and the tank sections. So those would be the big giant round sections. So yeah, we've chosen the WAM for that. And because we're just following what most people use in space flight, which are based on aluminium alloys. So in traditional rocket ships, those would be sheet metal. Maybe a 2000 series. And so we're kind of following in that kind of thought process. For the particular material that we use, we want to use something that is weldable by that advanced MIG process and that, you know, has a good solidification and can give you reasonable strength. So those are kind of key topics that we're looking for. We haven't placed a terrible amount of importance on, let's say, fatigue and fracture requirements right now, although those are obviously safety critical items, because right now we're only in a position where we just want to achieve first flight. We're not thinking about things that are going to be used multi-stage and so forth. What we have to do is just to demonstrate that technology is enough to get us in the air and to deploy the payload. So that's all we're focused on right now. So we have in mind that other people have reusable rockets. And so that is a goal. But for the first flight, that's not what we're really thinking about.
Great, thank you so much. What else do I have here? Almost always when I attend a talk about aerospace AM, it's all about metal AM. Which are speaker thoughts? When can we hear about FRP? Sorry, I lost the question. It's gone. Wait a second. I get it back.
Maybe enough to give an answer anyway.
Yeah, it is already enough. So when we talk, here is it. Which are speakers' thoughts when we can hear about FRP and CMC AM for aerospace high thermomechanical load applications? Jens, what do you think?
Well, when it comes to fiber reinforced polymers, so first we have a lot of polymers. I mean, Hauke could tell you about the number of polymer parts flying, which is significantly higher than metal. I leave it to you if you want, Hauke. But to finish my thought, to integrate fibers, it's not so easy. It's not just integrating fiber into common processes, because you need to really conquer the 3D directions, so the 3 fiber directions. And to do that is on a relatively low maturity, but it is worked on also within the Airbus group and Boeing, I think, as well. And when it comes to metal matrix composites, I think it is still in a niche, because also technology-wise, it is rather low technology readiness level. But I think you're probably also looking at it in terms of roadmap and strategy, Hauke, right?
I just can mention the question.
Well, yes, we
Go ahead.
We need to include it, but I like the general aspect of the question very much, because I agree. I totally agree that additive manufacturing, first of all, some people always talk about 3D printing or now AM, and they think it's one technology. It is not, and I guess all of our audience is very aware of that. But the benefits of additive manufacturing can be very different between metal technologies. Within metal, it's different between DD or metal powder bed fusion. But it's very different again for polymer technologies. And yes, Jens just mentioned it. So we have a 6-digit number of polymer parts flying today already. So more than 30,000 parts being produced every year at the moment. And this is a huge success, and it's even still, I would say, just the start of the story of the history. And a lot of most of the polymer AM technologies actually answer the initial 3D printing promises and expectations, which is not so much true for metal powder bed fusion in aerospace or in aviation for sure. It can be very complicated and long, whereas polymer technologies really can be very, very fast, very flexible, give a lot of design freedom. And so, yes, I absolutely agree. We shall not forget polymer. The benefits are huge, and it's absolutely already a reality in aerospace at Airbus for sure. Yeah.
So I would.
Yeah, no, I would agree.
Yeah.
We have a very small plastic printer, and we do use it for emergency parts or making tools or little spare widgets or something that you need to move something up, or spacers or shims or anything. And so we've never discounted the importance of polymers. Right now, we're just kind of not really focusing on it on our rocket itself. But that doesn't mean that it's discounted at all, because we have one and we use one. And then also, you know, the first 3D printer in space is a polymer printer. So that's on ISS right now. So polymers have a part to play, and they will become increasingly important.
So we have to come to an end. Sorry, guys, for that. But it was a very interesting conversation, discussion, which touched many parts in your area of activity. It was very exciting to see the combination where we have similarities and where we are far away from each other in the two industries. Exciting to see. For me, very important, Hauke, Jens, that aerospace industry is recovering soon, because I think this is something we are very proud of, how it developed the last couple of years and how big steps that have been done. And I hope with AM we can do that to bring that to a further or higher level again. Eliana, a lot of success with your rocket. I'm looking forward to see it in action all the time. And it was a pleasure to have you here. A lot of success. And enjoy the rest of the conference. And we will forward the rest of the questions to you. Stay in touch, okay? Thank you so much, guys. It was a pleasure to have you here. Bye-bye.